For the last plenary session, we're going to have a series of brief reports from each of the community breakout sessions. And then I'll invite if anybody else who led a breakout or an unconference session would like to give a similar informal report back, you'll be welcome to come up. And then Jeff Cantor needs to talk about some serious business. And then Steve Victor and or I will say brief parting words before we wrap things up. So to people that are going to come up, there's a number of you giving your report backs. There's a body mic here, but since most of the report backs are very short, you might find it easier just to use the podium mic. So let's get started with Pat talking about the blended objects breakout. Oh, and there's a laser pointer up here for everybody to use.
Okay, so I organized this. Let's see, is that blocking? Yeah. Okay. So I organized a session on blended objects, and it became, well, first of all, it was very well attended. We were 50% over capacity, so apologies for taking chairs from the other room. That was us. We were guilty. So there were about 60 people there, so a lot of you were actually at that session. And what was clear was that we had representation from, I think, all the different science collaborations, that it really became clear that there are three views of this challenge of blended objects. So crowded stellar fields, so crowded field photometry being the challenge there. Extended objects, so in the lower left. And the reason this is kind of a blending issue is because it became clear that detection and dealing with the blended objects are kind of go hand in hand. And so the detection can split up the extended objects. And so sometimes there's tension between the different types of challenges. And so in the lower right then is more of the dark energy kind of challenge of very small, faint objects that can become blended together. So Jim Bosch was at this session, and that was extremely useful. And he gave quite a detailed overview of what the plans are for data management in terms of blended objects. And so he showed this table. We're not going to go over the details here, but basically for the crowded stellar fields, and let's see if I can use this. Yeah. For the crowded stellar fields, and then deep high latitude fields. And here by deep we mean the entire survey. Okay, so it's not like the ultra deep fields, but the entire survey. Whether each of these things is a challenge for each of these different types of fields. And then at the bottom here, this is what I want to focus on, is that for the crowded stellar fields, the state of the art has mostly been solved outside LSST. Okay? Whereas for the deep high latitude fields where we're dealing with the overlapping galaxies, this is mostly unsolved anywhere, okay, for what we need. So this is just a summary of, and so he gave, if you want to see more details, go see his slides. For the crowded stellar fields, although processing crowded fields is formally a best effort task for data management, the community should expect us meaning DM, to do no worse than what they'd expect to get from running state-of-the-art third-party codes. It won't be that code, they'll rewrite everything, but the same quality. For blended galaxies, instead of, or in addition to, reapportioning flux, as in an SDS-style deblender, DM will just fit models simultaneously to all objects in a blend. And now this requires good models and probably good priors. It's computationally very expensive. And he emphasized that these, both the crowded fields and the blended galaxies, don't exist yet, the code in DM, but see his slides for plans and also for conjectures, okay, for his own personal conjectures about how this might be done. And then I think a really important thing that Jim told us about was how science collaborations can help. And you'll notice that running down these 4 bullets, there are some don'ts as well as do's. And so don't write a deblender unless you're very, very ambitious. And if you do, contact and work closely with DM. Do investigate detection, the first stage. The DM stacks algorithms are too far off what is expected in the future, and detection is critical for getting a decent hypothesis for the deblender and for simultaneous model fitting. So he views that as ready for feedback. Don't forecast prematurely. Think of the current deblender as more of a placeholder than a prototype, so don't start testing that yet. And then finally, do think about test cases, identify test data sets, and define metrics that DM could then use to evaluate the detection stage and eventually deblending and simultaneous fitting. And submit those tests to DM. If they're easy enough to run, they could potentially use them for optimization. So we then heard about some test data sets. So some of the science collaborations are already thinking about this. David Kirkby reported on a simulation package that he's been writing in the context of the dark energy science collaboration, but he showed examples of how the package is being used now and how other science collaborations might benefit from it. So I think an important thing about this session was getting different science collaborations in the same room so that we can potentially start sharing these tools. And Joseph Long and Harry Ferguson gave a tag team thing on the galaxies collaboration, and they're developing a training set of blended galaxy images from the candles data for evaluating deblending strategies, and he showed some preliminary results on using color information. So looking ahead to LSST 2017, I saw that the date has been announced. I think it would be really useful to have a couple of sessions like this next time, where potentially we could present and discuss test data sets, test cases, definitions of metrics, et cetera, for, again, all the stages, detection algorithms, deblender, and simultaneous fitting. And in between now and then, the detection part, I think we could already be evaluating. And so there was discussion about using the community forum and starting a separate blending section over there, where all science collaborations could see what the others are doing, because, for example, dark energy science collaboration, we're usually within a password-protected Confluence area, so it'd be nice to have something out in the community forum for that as well. And finally, this is just from our page, what the session was. And I just want to emphasize that anyone who wants to know more about this, we linked a couple of resources down here. And for example, Jim Bosch has written a blended measurement paper. And what's really, I think, interesting, too, is the follow-up discussion in GitHub and in community forum about all this. So that's what we did. Thank you.
And so if people could write down their questions and take them at the end, just because we're going to have about 8 short talks, and I want to make sure we get them in before people have to run to the airport. Please. Oh, yes, Jim.
I don't want to, the simultaneous fitting is not something we're definitely going to do. It was one of several things we're going to try.
Thank you for that clarification. And folks who are on blue jeans, I'm trying. I don't know what's going on. So I bring up.
Okay, so I organized a session which was called End-to-End Galsim. So what does that mean? Galsim is an open source software package, and a lot of people use it in the community, but typically it's used for sort of simulating postage size images of galaxies to test algorithms and things. And so what it means in this context is generating a set of LSST relevant modules or codes that allow us to really do all the steps necessary to completely characterize the telescope. So that means reading in instance catalogs, propagating these sources through a realistically modeled turbulent atmosphere, further perturbing the wavefront as it passes through the aberrated optics, propagating into the individual photons into a physics-based LSST sensor model. Okay. And then writing out the resulting full focal plane images in the proper LSST camera and chip geometry, including the entire readout chain. And so there's a lot of people who are actually doing pieces of work already about this, and the sort of idea behind this session was to see the big picture of how this all fitted together and what we needed to do to get this all working together and finalize something that was actually working. So what I'm going to do, since I only have a couple minutes, is just go through a little bit of something that each person said, and I encourage you to go to the web page and you can see the talks from each of these people. So the first person who talked was Scott Daniels from Washington, and he talked about how he's already written code that can query CatSim, which is the database of all the objects that has the Millennium simulation in it, and return those objects and pass them into the Galsim image engine. And then we talked about the ability to add the ability to read current instance files, so that we have instance files now for FOSIM, so we should just be able to ingest those and read the same thing. So then Josh Myers from Slack talked about his work on the atmosphere. So this is very interesting because he's done a lot of work with Fourier optics already, with sort of making donuts going through the atmosphere through these various layers, and he's done studies where he's tried to understand how things run as a function of frequency. So this is kind of the lambda over 5 relationship that you might expect if there was some outer scale, and he's seeing something that's slightly different. So we're studying that to try to understand how this should depend on frequency, and then he's starting to implement a ray tracing version of this through the atmosphere, which will be fast enough that we can actually use it in normal running, and this is a technique which has been very much already well tested and validated in other tools that we have inside of LSST. So then we heard 2 very interesting talks from systems engineering from Bo Shin at LSST and also from Aaron Rudman at Slack. And so systems engineering has a very sort of amazing model of the active optics. So here's a model of the telescope, and they have sort of, I guess, 50 degrees of freedom where they can change the bending modes on each mirror plus the camera hexapods. And then what they've done is they've, using Zmax and FOSIM, they've simulated the sort of perturbative effects that you get in annular Zernikeys at several points on the focal plane as a function of these degrees of freedom. So in other words, if you move one of these bending modes by a certain amount, how much aberration does that give you in the optical plane? And so Aaron talked about how we can take the input of this model, which has been generated by the systems engineering team, and propagate it through these individual deviations, how we can add those to the model that we already have for perfect optics so that we can model that optical system inside of Galsim. Okay, so this is an awesome picture that I wrote on a whiteboard, so you obviously can't extract information of this. But what's going on here is there's a lot of people in the project and in the science collaborations now who are working on very careful physics-based simulations of the sensors. So things like the brighter, fatter effect and tree ring. So Andy Rasmussen is working on that, Craig Lage at UC Davis. And what we want to do is make the API. So we've heard a lot of talks about that, but what we talked about today, or yesterday, was how we can make the API to fit those pieces in. So this is a picture which is showing you these are photons coming in. These are effects that happen at the surface, like AR coatings and fringing, which changes the conversion point. This is the silicon transfer, and this is the readout chain. So Mike Jarvis, who's one of the main Galsim developers, is working on the API that will allow people to plug their code in. So you can look in details in his talk, but this is sort of showing you the API where you can plug in different models. So the idea is we want to work with the data that's coming out of the test stands from the various laboratories and have a set of standard plots that we can validate against as we try different models to test how of these different sensor models are working. So we want to automate that process so we can really validate the sensor model. Okay, so finally, the last step, it's important to actually take the output of that and write things out in a realistic way. So Jim Chang at Slack has written a realistic readout chain that outputs the data that looks like the real camera test stands driven by CSS. And here you have, he's done this for both sensors. This is for both the I2L and the E2V sensor. And actually this discussion, I think, was very important because it made us start to think about where is the centralized information about the camera geometry and all of the information about the sensors, and how do we store that? Right now it's spread around in a few different places, so we need to centralize that together so that all the software reads everything in the same place. So I encourage you to go and look at these slides, and I think we saw with all of these things together that all of these pieces are together now, and so we're working on merging them all together and getting something that actually works. And it was really nice, I think, to be in an environment where we could all understand what was going on and see how things were working together and how they would come together to make something that we can all use in a short time scale. Thanks.
Okay, Phil, do you know which is the first talk in this next slide deck? Thanks, Harry. Computer's starting to fight back. Everyone knows that rainbow wheel. So you can use this. Do you want to stand there and use it, or you can talk about it? The switch and turn it on. Still good.
Okay, so Brant Robertson had to leave, so he sent me a slide. This was a session that was to talk about and maybe share notes about road mapping efforts. And I would say maybe a little bit hampered because a lot of the people who are engaged in those aren't at the meeting, or weren't at this meeting anyway. So he tried to summarize what he knew of the road mapping in general, and then we had a couple presentations, one on sort of precursor science with the Hyper Supreme Cam from Jeff Carlin, and one on the Australian potential contributions by Simon Driver. Just to give a quick summary, he tried to outline what he knew of road mapping efforts that are underway. And so, of course, the DESC has led the way on all of this. AGN is working on road mapping. There's a sort of a general extragalactic roadmap, which includes AGN, and I don't think it's yet been reconciled, whether they will be completely separate or merged. There's Milky Way local volume, stellar populations, one, and then transient variables, and then the solar system has also got a road mapping effort underway. So there is work going on. As far as the extragalactic one goes, which is the one he knows the most about, that's been re-energized quite recently with the influx of especially the UK participants. There was a meeting of the dark energy collaboration as well as the galaxies collaboration in the UK last month, and a lot of discussion on road mapping. There are now working groups, and there's a plan to revive that road map and get it going. And so he left with his email, and at least for the extragalactic roadmap, he's the person who's leading the way on that now, and there are working groups established, and there'll actually be some real writing starting on that. That's probably all I need to do for the summary of that right now.
Kind of mentally prepare who's next. Is Philly next? Richard, have you heard any more blue jeans, or are we still going? Okay. We're good? Thanks. Great job there. Feedback for some reason.
All right.
There you go.
All right, so I'm presenting a summary for Peter Joachim, who unfortunately had to leave this morning. He was going to go give this little presentation to you. And the reason is that Peter enabled a lot of activity in the hack session by providing an excellent IPython notebook to get people started on developing a particular kind of metric for observing strategy analysis. So here's an example result from that notebook where Peter has simulated a small population of toy transient objects and then asked in a sort of toy way, would we be able to detect those? So you're seeing a scatter plot where yellow objects are successful detections and maroon points show the failed detections. So this is very helpful, and a number of people were able to work on this, and it reminded me of a key feature for if you're organizing a hack session. It's good to seed them with things like this to enable people to make progress quickly on their own little projects. Okay, so you can find this notebook in the Sims Math Contrib repo, and that's a hyperlink there if you want to download the slides. Okay, so what else did people do? I picked out a couple of highlights that I thought were interesting. If you remember in the plenary session, Peter Melchior asked some good questions about seeing for weak lensing. And so in the hack session, he and Josh Myers got together and made a plot together. So here you can see a sky map of the 10th percentile seeing. So they're interested in the best seeing stacks as a way of helping detection and supporting the weak lensing analysis. And so this is showing some variation over the footprint. I like their sentence here. It appears that our ability to identify blends may vary considerably over the survey footprint. As well as working on the metric analysis, we had people who were thinking a bit about how they would like to see OPSIM run over the next year. And in particular, we had two starter proposals put onto the suggestion board that we have on the GitHub site. One for supporting the Euclid satellite and another for supporting the W1 satellite. So Andy Connolly worked on a proposed observing strategy that would help out a bit with the Euclid weak lensing program, and Radek Pilecki started the proposal for supporting the W1 microlensing survey, which I think would be a micro survey to add to our suite. I thought I'd also report a little bit on the conference last night. Michael Strauss stimulated and then guided a very good discussion of what's going to be happening with OPSIM over the next year, and that led to more discussion of what's going to be happening with the white paper over the next year. So the key thing to keep in mind is that November is when we expect there to be a new release of the OPSIM code. And we're particularly excited about the ability of that code to support rolling cadence strategies, which a number of science groups are interested in. These are strategies that enable you to get higher frequency sampling over small patches of sky, or fractions of the survey perhaps. And so we heard from Andy Connolly that it's useful for the OPSIM team if we in the observing strategy community suggest some rolling cadence proposals to put into OPSIM so that they can check that the code is going to be able to support them. So we'll do that over the next couple of months. The data from the Operation Simulator, the new version, should be available in spring, we're told. So April is the date we sort of have in mind for starting analyses of those new simulations. And we think that we ought to be able to do some metric analysis on those new simulations and then report back to you next time we meet here. And so that could be a good time to try and put out a version 2 of the white paper. So begs the question, what about version 1? We're aiming to get that to the LSST publication board in around September time. We have a few things that we need to do following this meeting. So, for example, getting the metric analyses all using the same baseline cadence, for example. There's also some editorial work that I need to do. And we decided last night that the group would carry on working on the master branch, and they didn't want to be slowed down by things like, releasing papers. So I agreed to try and handle that process by making separate branches and dealing with all the review. So we'll see how that goes. This is the first time we've tried to really review a living document, and because there's so much excitement about observing strategy, it's quite a fast-moving document now. So and that's great for all of you, and an interesting challenge for me. Thanks.
I really shouldn't try to walk up the steps while putting the microphone on. I just realized that was potentially really bad. So on Wednesday, we had 2 event brokering sessions that sort of segued into a broader discussion about time domain, follow-up, and alerts and things like that. And I want to point out that Ashish Mahabal was the co-leader for these things, so it was the both of us who sort of put this thing together. So we talked about we started off with discussions about the fact that there are actually, right now, wide field time domain optical surveys going on. So we don't have to wait for LSST, there's actually these things happening now. And so Eric Bellum reported on the transition from the intermediate Palomar Transient Factory to the Zwicky Transient Factory. When that comes in operation, it's gonna have a 47 square degree camera, and you can see it's gonna do almost 3,800 square degrees per hour. And so when it is in full-scale operation, it will rival LSST for what LSST can do at the bright end of its range in terms of producing transients. So we'll already have a large volume of alerts coming out as soon as this is operational. PTF has used an internal broker that is intimately tied to its own data pipeline, so it's not a separate entity that does the filtering of the alerts. And it's geared to very specific science goals within the program, so it can't do the full broad range of science that you might want to accomplish for, say, the LSST alert stream. And the other thing is that there's a lot of human involvement in the end in vetting these alerts. So even though there are automated elements to it, there's still a considerable number of eyeballs that end up looking at these alerts and deciding what are the interesting things to follow and what are the things not to follow. But because ZTF was funded through an MSIP grant, there's public money in it, which means there has to be a public component to the survey, and that means that there will be publicly available alerts when it is in operation. About half of the alerts from ZTF will be made public starting in 2018. So that's not that far off, but we're actually going to have an enormous volume of alerts, and we're going to need to be prepared to start dealing with that, relatively soon. Eric Christensen talked about the Catalina Sky Survey, which is operating on a mountaintop just about, well, I don't know how many miles that direction from here. And they are doing an NEO-optimized survey. And they are already at the point where they can get up to 1 million alerts per night. Again, a very large scale that they're already operating on. And they have an automated system to vet their tracklets. But again, they still have people who are looking at the best candidates to decide what they will actually pursue and follow up. So even though in both of these surveys they have some automated systems, they still end up relying on people to do the final solution. Now this is not going to be scalable to LSST, so we still have to make that final gap bridge that final gap of getting the automated evaluation to the point where it can narrow things down to a much smaller number. But because they do have this system where they have the people able to look at it through the course of the night, the telescope operator is one of the people who can vet them. They have same-night follow-up capability, and so they're able to find NEOs pretty regularly that are legitimate NEOs and not spurious targets. So then we went on and talked about sort of some things that are going on right now in dealing with alerts. So Ashish talked about Skylert, which is one of the pioneering event brokers. It enabled people to get alerts with annotation. They were filtering. People could put in rules. They could subscribe in different ways to different things so you could sort of see what you wanted from the alert streams that they were sampling. Now, it's no longer operating right now just because the machine that it was on at Caltech has died. So, but there may be ways to revive that. The point is that that the architecture for Skylert is still operable and still useful, and we can learn from it to take elements of it to scale up to what you might want to have in the LSST era. Darko Jevromovic talked about his development of the Alert Sim. This takes products from the LSST SIMS team, the OpSim and CADSim, and tries to generate a realistic alert stream right now that would simulate what you would get from an actual LSST night of operations. This is useful to have so we can have something that we can test and train on actual alerts that represent the format or at least the style that we will get in operations. And right now it's focused mainly on stellar variables, but he's working to expand that to extragalactic and solar system objects so that this thing can become a more faithful and realistic simulation of the alert stream that will come eventually from LSST. Next, I gave a presentation about one of the broker projects that we're working on here. So this is the Antares project. This is a joint collaboration between NOAO and the Department of Computer Science at the University of Arizona. And it's been a really productive and fruitful collaboration to have expertise in database design and visualization and algorithms to couple with astronomical knowledge to produce the kind of software infrastructure you need to build a broker. So the plan was to build a prototype that can do most of what you would want in a broker that is scalable to LSST rate and volume. And we have a full software infrastructure in place right now. We can start alerts at the top. They go through the full system. We can annotate them with association with known objects. We can look at past history on alert sites. We can see what among those things look like they are rare or unusual and find out what the things are within that alert stream to follow up. And we're running on a cluster that we just installed at the University of Arizona for testing purposes. But what we need is we need community involvement to help us build all of the astronomical filters that you'd want to have. This requires a breadth of astronomical knowledge that the people who are working on it within NOAO don't necessarily have. So we need help from the community for everything that people want to be able to distinguish within the alert stream. And to that end, we've talked about building a data challenge. And so this is something in collaboration with the entire transient variable collaboration about creating a challenge where we can provide example data and people can see what they would need in order to distinguish the object that's of interest to them. So it's a question of what kind of alert data do you need? What's necessary and sufficient to characterize your object? What ancillary data, aside from what LSST might provide, is necessary or sufficient? Do you need to know if there's a radio source there or an X-ray source or what type of galaxy is nearby? So we would like to, within the context of the transient variable collaboration, we're going to set up this data challenge. I was just about to put a new topic on community.lsst.org about this very thing, and then Phil ended and I had to come up here. So in a few minutes, it will be on there, and we will have a brief outline of what we intend to do and how we want people to try to help us by providing data and then thinking about how you would actually use the minimum amount of information to identify things as rapidly as possible. So that leads into the bigger idea of once you've identified things, how do we have this whole time domain ecosystem to conduct the follow-up and do the actual science with the results of these vetting of these alerts. And so Rachel Street gave a great talk about time domain infrastructure and summarizing what the chapter that she wrote for that Kavli report that Beth mentioned a couple of days ago. And there were many recommendations from that, most of which had to focus on the need to develop many kinds of infrastructure tools for LSST. This includes brokers, but there are many other things that need to be in place to have an efficient and operational time domain system. We need to have data reduction pipelines, we need to have data management systems, telescope scheduling systems. All these things are not yet there in a way that we need them to be to have an efficient and productive follow-up system, especially for the scale of what LSST will require. And in addition to that, in the time domain world, it requires a sociological change. There needs to be more information sharing and data sharing about if someone's followed something up and they know it's not anything interesting, the rest of us need to know that so we don't go waste time on it too. We don't want to be all looking at the same thing. We need to be more efficient than how we've done things in the past. And this has been a particular problem in the time domain community of learning how to share. And so this is a significant change, but it has to happen or we're going to make mistakes and things will fall through the cracks because we can't afford that when the LSST rate and flow is coming. So we need to be mindful of that. But the other thing she pointed out is using existing surveys to develop and test this, which leads directly into the next topic, and that was Todd Borison came and talked about this new MSIP opportunity with the Las Cumbres Observatory Global Telescope Network. Las Cumbres has been awarded an MSIP, money so that NSF has essentially bought time for the community from LCOGT. Starting next year, we are going to have 1,300 1-meter hours and 200 2-meter hours per semester for 7 semesters. This is an enormous amount of time on a very efficient worldwide system of telescopes that are exactly designed to do time domain follow-up. And so this is a great opportunity now that we can build and test infrastructure to prepare for what LSST is going to do. This is no longer sitting around talking about, oh, in a few years we will have to build a system where we can virtually model it. We actually have real telescopes, real surveys right now to do follow-up. We can build infrastructure and do the science now to be ready for what LSST will provide us in the end. And the NSF explicitly wants this time to be used for LSST preparation. So that's where the proposals are going to be weighted highest, is the things that want to build the system for what we will need from LSST. So because of this opportunity and because of all the other things that we need to start thinking about for how we're going to have scalable brokers in the era of LSST, NOAO and LCOGT are going to be running a workshop next May here in Tucson. And so we'll want to talk about the infrastructure for time domain science in the LSST era. This will include a lot of technical stuff about how alerts are processed and handled and how they're brokered and how we distribute things. But also we're going to make sure that we have a couple of days or 1.5 days where we can have people talk about what you would do with the LCOGT system to construct a coherent and efficient and broadly scaled time domain follow-up system that you could use to really test what people want to do in the LSST era. So I hope that everyone who's interested in this can come next May, because I think this is where we're going to have some really interesting discussions and decide how we're going to try to move forward in being ready to do time domain science when LSST comes online. Thank you.
Okay, so I'm going to report on the breakout session on atmospheric data and modeling that we had yesterday afternoon. So we saw on Tuesday night a pretty dramatic example of how the atmosphere can is highly variable, both in time, that thunderstorm came in really quickly, but also spatially. You can see we have blue sky over here starting the sunset and then rain over there. And we're going to have the same issues in LSST because of the short exposure times and because of the wide field of view. And so when we talk about atmosphere, there's really three separate things. There's the sky background that gets added to our images, there's the extinction of our sources, and then there's the significant contribution to this point spread function. And usually we treat these as separate things. So part of the goal of this workshop, of this breakout, was to bring together the people working on these different aspects, just to be aware of what others were working on and kind of identify some areas of overlap. So I took good notes during Beth's meetings 101 yesterday. So I started our session with desired outcomes of this breakout session. We wanted to introduce the community to the project experts on the atmosphere. We wanted to develop connections within the project and between the project and the community, and then also identify opportunities for future collaboration going forward. And so the way we accomplish this is we all listen to some brief overviews spanning current work. There's a lot of detailed work, so we weren't able to get into any of the details. And we wanted to discuss synergies between existing efforts. We didn't have enough time for that, so we could definitely use more. And then to follow up by email to develop these collaborations and schedule some future presentations of the work that comes out of that. So we heard this is a project and community workshop. So we heard from on the project side, Chris reported on the calibration team's perspective. Peter reported on the simulation team's work on the atmosphere. And although we didn't have our presentation, Robert and Merlin were there representing DM and gave us some useful input and perspective. And then on the community side, Josh is giving his trademark demonstration of the layers in the atmosphere. And then Dan and Steve reported on what we can learn from existing data sets about the challenges of the atmosphere in LSST. So Dan was focusing on, has been mining the huge number of sky spectra from SDSS, in particular from BOSS. And then Steve talked about what we can learn from DES data. And Dan focused on the variability of the OH emission, which really dominates in the red end, and interestingly has looks like something to worry about with the causing variable fringing. So I can tell you more about that later if you're interested. And Steve was looking at the feasibility of using global circulation climate models, basically to help nail down what's actually going on in the atmosphere above LSST. Okay, and then since we're talking about the atmosphere, just to finish up, so I wanted to see if anyone here has any idea what's going on in this photo. So this is a photo that I took on Monday night, and this is looking west. So this is not the sunlight or corpuscular rays. And there's, for astronomical context, there's the moon. So I have no idea what this was. I think it's clouds, but I don't know. And if any of the locals have seen this before.
This is anti-corpuscular rays. It's a continuation from corpuscular rays going all the way across.
Converging in the west.
Yes. It's parallel, but it's like railroad tracks. Yes. So it just looks like it's converging.
Okay. Great. Okay. Thank you. So that's all.
Okay, great. Thank you to all of our breakout leads, and thank you for your patience with adding more questions or comments. Did anybody else who either attended these breakouts want to add a comment, or did anybody have questions for any of our breakout leads? Please, Steve Ridgway. Oh. I'm going to get your slides. My computer's like, no more working. Okay. Did you put them on the agenda page right before, like, I took everything about the 10:55.
Just to get things started, Neil Brandt organized a breakout on deep drilling and other mini surveys.
I thought those were good.
And I just made a number of highlights, which may appear shortly. The first is that mini surveys and perhaps something you can call micro surveys are a part of the LSST plan, nominally designated at up to 10% of the time, although one hears discussions about reasons why that might possibly be considered a larger fraction, depending on evaluations coming in the future. The emphasis has been that although 4 deep drilling fields have been selected, that is only a partial commitment of the available time, and that and I would also say that there are simulations using a variety of other deep drilling and mini survey proposals, but they're not a commitment to do those. They're computer experiments. So Neil reviewed a variety of great ideas that have been proposed for both for additional deep drilling and for mini surveys. There's a large variety. We noted that there are many metrics available that can be applied to those proposals. In approximately November, as you've heard, there will be a new version of the simulator which will correct some problems that have in fact been very serious for the mini surveys and prevented them from providing realistic cadences. Those are expected to be resolved in a few months, and that and other additional capabilities will appear with simulations sometime after November. We've been suggesting perhaps April, maybe sooner than that. Gregory Dubois-Felsman discussed data processing and DM commitments, how they would apply to mini surveys. He made very strongly the point that data management is only promising standard wide, fast, deep processing for mini surveys. That's what's promised and that's what's budgeted. But he encouraged the community, particularly those persons interested in mini surveys and deep drilling, to think about the actual requirements, and if you don't ask, you won't receive, surely, and you certainly should be aware, and the community should be aware of the needs and how and if they will be met. He gave some examples, such as the fact that a deep drilling program, as currently conceived, could consist of many rapid exposures, which raises interesting questions. Are alerts generated on each exposure? Are the exposures stacked and then alerts generated on that? If alerts are generated on shorter exposures, it produces a possible timing problem. And other questions such as how the data is handled in cataloging with respect to regular wide field deep survey catalog. So he encourages us to consider what kind of processing is appropriate and suggests continuing the conversation on the community LSST org site.
Any questions for any of our breakout reports so far? Anyone else who participated in an unconference session? I know we already heard from Phil about one of the main ones, or anyone else who led a breakout session on the project side of the house want to give informal words? And I'd like to invite Jeff Cantor up. Jeff, you in? There you are, Jeff. Apologies to people on blue jeans. You might not see this video that Jeff's about to share.
Okay, so as a joint NSF-DOE project, we of course have to provide earned value measures for everything we do, including these conferences. And so I have a proposal here for an activity which can be engaged in by both scientists and engineers. It has assigned resources, a specific period of time, very measurable outcomes, and I'd like to propose that we adopt this as one of our primary earned value metrics. I know Felipe is here, but thanks to Felipe Darwich for, there he is right there, for running around with a GoPro on the field. And to everyone who played. Many thanks to the Westin La Paloma for making the facilities available, bringing us water, putting signs out there. We even had 2 fans who came out to watch, although that's what they told me. And it's not clear to me that they didn't just take the wrong turn before the thing. But anyway, everybody. And we'll do it again next time. And with that, Victor has a couple of slides. I'm going to throw those up here for him. I'm not absolutely sure.
I'm not quite sure how I follow up with that. But what I did want to tell you is that I apologize that this very last session of the last day is the first session that I've actually been able to participate in. And the reason for that is you may have noticed that for the last 3.5 days that we were actually hosting a team of 26 reviewers and agency representatives as they conducted the status review for the year. This is the first time that we actually hosted one of these where the NSF and the DOE jointly came in to review our status, and it was quite an exercise. And unfortunately, in hindsight, we scheduled it right in the middle of this community workshop, or our all-hands meeting, and so it left us with a lot of things going on, and many of us couldn't participate like we would normally have. So it's nice to have seen some of the out briefings here and see what you guys were all doing while we were just hanging out downstairs. What I did want to just tell you really quick is that there were very specific items that they came here to look at, and here were the 6 charge questions. I think there's six or seven. And in general, they were happy with the status of the overall project, and specifically that the technical accomplishments to date were consistent with our plan. They did recognize, however, that the DM team is doing excellent work and they are making good progress, but with the replan in progress, it was a little bit hard to measure that progress to an end goal. And that was recognized, and we had a good plan and stated exactly what we were doing in the near term to rectify that. Also, that our cost and schedule performance was consistent. We have good enough contingency in place, and so that's all looking good. That we have good management processes in place that indicate that we are likely to succeed and bring the project in time, on budget, and to performance. They liked the status of our safety performance, and that the safety culture within the project is good, that everybody takes it seriously. The engineering teams are engaged and working hard to design out any of those safety hazards for good, safe operation. There's often a lot of attention on transition to operations. So Dr. Willman did a fine job many, many occasions throughout this process to convince them that we are actually thinking about how we're going to operate, and that we do have a plan to get from construction through commissioning and into operations in a seamless and efficient manner. And then lastly, they came and were just checking to see that we were paying attention to previous reviews and whether we actually followed up on the previous actions. And so I think it was a very successful review. I think there's still a few remnants of those 26 people around, and I appreciate that they came. And as difficult as it is to support a review like that, I think it does help the project. It does bring us all together. That forces the team to sort of put their thoughts in one place and recognize their own accomplishments. And while I also hope that next year we don't run that meeting at the same time as this all-hands meeting, that we will continue to do these reviews and continue to show the good work that the team is doing. That's it. That's my outbrief. Dr. Khan has nothing else to add. Oh, no, you're welcome to give the last 2 slides. I haven't had quality time on the stage. On this stage.
The other stage, plenty. And I'm just going to do that. Okay. I'm only taking 2 more of your minutes, I promise. This is the thank you bye slide. Great. So this is the 3rd time I've shown this slide this week, and it can't be enough, as you've heard. This is the set of folks that were both behind the scenes on the support staff and also on the formal organizing committees, arranging not just the project and community workshop part of the week, but also the status reviews that were taking place in, 6 or 7 parallel rooms at the same time for part of the week, as well as a number of intensive plenary sessions that involved a lot of last-minute late responses to reviewer homework, updating of the web pages, updating the materials. And so we had a lot of actual science and engineering team members who aren't on here who did that homework, and then a lot of support staff who had to respond to it really quickly. And the week went seamlessly, and large thanks to them. And, I took Victor and my picture off the slide because, But Victor especially has done an enormous amount of last-minute shepherding over the last week and responding to the reviewers, as well as Steve, who's been sitting quietly, soaking in the last-minute science. And so thanks to both of you, too, for really helping making this work out and working to make the review go seamlessly in the midst of all the insanity. So our annual LSST 2016 exit survey is ready for your input. We're going to be here the same time, same place next year, so your survey input is as important as ever. I've already heard some constructive feedback, for example, about how friendly the food's been to vegans and vegetarians. Don't not say that on your survey because I just told you I've been hearing that, but that's an example of something that, I don't know, I'm not the people talking to the catering department, but it sounds like something that's fairly straightforward to address, and we would love to hear that kind of feedback so that we can make next year even better than this year. Here's our fine group photo, which I believe will be sent out in the weekly digest. I think the next weekly digest will probably be today. So I want to thank you all for coming, and again, I want to thank everyone in this slide and Steve and Victor for making this week a success. So let's think about them as we give our final applause. And I know a lot of you still have meetings. I'll see you all next year. Enjoy. Thank you for coming.